November 7th, 1944. 1400 hours, Schmidt, Germany, Hürtgen Forest. Oberst Engel, commanding the 275th Infantry Division, stood in his command bunker, studying reports from forward positions with growing disbelief. American infantry from the 28th Infantry Division had been attacking through the dense forest for 3 days, making minimal progress against prepared German defensive positions. Standard American tactics, Engel thought. Poorly coordinated, overly cautious, reliant on material superiority rather than tactical sophistication. The Americans had called for artillery support 17 times that morning. Each request had been answered by scattered, uncoordinated fire from what German forward observers estimated were individual batteries, perhaps 3 or 4 guns firing in loose sequence. Preparing and narrating this type of story took us long efforts and hard work. So if you are enjoying the story, please consider subscribing to our channel. German artillery doctrine, refined through 5 years of war across 3 continents, emphasized rapid concentration and flexible response. A single German battery commander working with forward observers could bring accurate fire on targets within minutes, shifting fires quickly to support changing tactical situations. Engel's own division artillery, though depleted by years of combat, could still coordinate 4 batteries to concentrate on a single point within 8 minutes. The Americans, by contrast, seemed to spread their abundant artillery across the front with little coordination. Their forward observers called for fire from nearby batteries, achieving local effect but lacking the concentrated punch that German Schwerpunkt doctrine demanded. It was wasteful, inefficient, typically American, quantity attempting to substitute for quality. At 1403, Engel's telephone rang. His forward observer, near the Kull River crossing, reported American infantry movement, approximately 2 companies massing for what appeared to be another assault on the Schmidt approaches. Engel authorized his artillery to prepare defensive fires. Standard procedure. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. At 1406, the Americans requested artillery support. Engel expected the usual response, scattered fire from 3 or 4 nearby batteries, enough to make his troops keep their heads down, but nothing his veterans couldn't handle. What happened at 1407 would fundamentally alter Engel's understanding of how the Americans fought their wars. Exactly 12 American artillery battalions, 144 guns ranging from 105mm howitzers to 155mm guns, fired in perfect unison. The shells, launched from distances spanning 5 to 15 miles across multiple corps boundaries, had been calculated to arrive at precisely the same instant on a coordinate square, measuring only 400 meters on each side. The concentration of firepower was unlike anything Engel had experienced, and he was a veteran of Stalingrad. Over 3,000 shells fell on his forward positions in 90 seconds. The earth shook so violently that his bunker, constructed with reinforced concrete and buried under 6 feet of timber and soil, lost electrical power. Dust filled the air. Communication lines went dead. When contact was finally re-established 30 minutes later, Engel learned that his entire forward battalion, nearly 500 men in prepared positions, had been effectively destroyed. Not scattered, not forced to retreat, but annihilated by artillery fire that arrived with mathematical precision from batteries his men had never seen, coordinated by a system they had not imagined possible. The Americans had not fired more shells than expected. They had fired them all at once, concentrating 12 battalions worth of firepower on a single moment in space and time. German artillery doctrine had no answer for this. German assumptions about American military incompetence required immediate revision. To understand what the Germans encountered at Schmidt, one must first comprehend the state of artillery doctrine in 1944 and the fundamental assumptions that shaped military thinking on both sides. Artillery had been called the king of battle since Napoleon, but its employment had followed predictable patterns for over a century. The Germans had spent 5 years perfecting their artillery doctrine. Schwerpunkt, the principle of concentrated force at decisive points, governed all German tactical thinking. German artillery achieved concentration through careful positioning, detailed planning, and flexible command structures that allowed battery commanders to shift fires rapidly. A German artillery officer with proper training and adequate communications could bring devastating fire on targets quickly. This flexibility had served Germany well in Poland, where concentrated artillery prepared the way for panzer breakthroughs. It had worked in France, where mobile artillery supported the rapid advances through the Ardennes. It had been essential in Russia, where German artillery repeatedly concentrated to smash Soviet strongpoints. By 1944, the Wehrmacht considered itself the master of artillery employment. German forward observers, the Vorgeschobener Beobachter, were extensively trained officers who worked intimately with battery commanders. They understood ballistics, could estimate ranges accurately, and could adjust fire quickly. The system was professional, efficient, and proven in combat. American artillery in early encounters had seemed amateurish by comparison. At Kasserine Pass in Tunisia in February 1943, American artillery had been dispersed, poorly coordinated, unable to concentrate fires effectively. German after-action reports from North Africa consistently noted American artillery as abundant but uncoordinated, firing in a wasteful, scattered manner that suggested poor training and inadequate command structures. This assessment was not entirely wrong based on those early encounters. The American Army of 1942 was indeed poorly trained by European standards. It lacked combat experience, had not refined its doctrine through years of war, and was still learning how to coordinate the massive amounts of equipment its industry could produce. But the Germans had made a critical error in their analysis. They had assumed that American performance in early 1943 represented fundamental limitations rather than temporary inexperience. They had not recognized that the Americans were systematically studying their failures, developing new procedures, and creating organizational structures that would transform artillery from individual batteries into an integrated system. The development of what the Americans would call massed fires represented a fundamental shift in thinking about artillery employment. Rather than seeing artillery as batteries supporting local commanders, American planners conceived of artillery as a system, a network that could deliver overwhelming force at precise moments through centralized coordination. This required innovations that German doctrine had not anticipated. First came the American forward observer system, which differed fundamentally from German practice. Unlike German observers who typically worked with specific batteries, American forward observers could call upon entire artillery groups, even corps-level assets they had never met. Each American forward observer carried SCR radio sets, providing reliable communication to fire direction centers miles behind the lines. The SCR 619, operating on FM frequencies between 27 and 38.9 MHz, gave forward observers direct connection to fire direction centers that could task any available artillery within range. This meant an American lieutenant with a radio could bring fire from 20 or 30 batteries, spread across 15 miles of front, none of which belonged to his division, most of which he could not see. German observers, by contrast, typically worked with 4 to 8 guns they knew personally, coordinating through telephone lines vulnerable to artillery fire. The second innovation was the Fire Direction Center, a concept the Americans had pioneered at Fort Sill in the 1930s and perfected through combat experience. The Fire Direction Center was essentially a mathematical computation center where trained personnel used firing tables, graphical firing boards, and standardized procedures to compute firing solutions for multiple batteries concurrently. A typical American Corps Fire Direction Center in late 1944 might coordinate 20 to 30 battalions, calculating firing data for hundreds of guns simultaneously. The personnel were not artillery officers in the traditional European sense. Many were enlisted men trained specifically in the mathematics of ballistics, using tools like the graphical firing table that allowed rapid calculation of complex trajectory problems. The third element was communication infrastructure. The Americans laid communication wire with systematic intensity that astonished German intelligence. A single American infantry division might lay over 3,000 miles of wire in a month of operations, creating redundant networks that ensured fire missions could be transmitted instantly even under heavy artillery fire. Combined with radio networks operating on multiple frequencies, This communication superiority meant that American fire direction centers could coordinate fires across corps and even army boundaries. A forward observer in the 28th Infantry Division could request fire from batteries belonging to the 5th Corps, 7th Corps, or independent artillery groups, all calculated and delivered within minutes. The fourth and most crucial element was standardization. American ammunition was manufactured to exact specifications in factories from Pennsylvania to Illinois. A 105mm shell produced in Rock Island Arsenal would have identical ballistic characteristics to one produced in Watervliet Arsenal. This consistency enabled the precise calculations required for massed fires. German ammunition, increasingly produced by slave labor in dispersed facilities subjected to Allied bombing, showed growing variability. German battery commanders had to conduct test fires with new ammunition lots to determine actual muzzle velocity and range, compensating for inconsistent propellant quality and shell weight variations. Americans could assume their ammunition would perform exactly to specification. The concept of massing fires from dispersed batteries had been developing throughout the American campaigns in North Africa, Sicily, and Italy. The 9th Infantry Division had experimented with coordinated fires in Sicily in July 1943. The 1st Infantry Division had refined techniques during the Italian campaign, discovering that shells fired from different distances could be coordinated to arrive simultaneously through careful timing. By the Normandy invasion in June 1944, the technique had evolved into formal doctrine. Fire direction centers now routinely calculated what they called time-on-target missions, where shells from multiple batteries converged on a single point at a predetermined moment. But these early missions typically involved 4 to 8 battalions, impressive but not yet overwhelming. The Germans had encountered these coordinated fires in Normandy and had been impressed but not alarmed. Concentrated firepower was nothing new. The Soviets had demonstrated massive artillery concentrations on the Eastern Front, sometimes massing 200 guns per kilometer of front. The difference was that Soviet artillery achieved concentration through physical massing, moving hundreds of guns to a single sector for major offensives. American massed fires achieved concentration without physical massing. Batteries spread over 20 miles could deliver their shells to a single point without ever moving. This distinction was subtle but profound. It meant American artillery could concentrate instantly on any target within range, then shift to another target just as quickly, achieving flexibility that physically massed artillery could not match. The Battle of the Hürtgen Forest, which began in September 1944 and would continue until February 1945, became the proving ground for American massed fires doctrine. The forest itself, dense woodland covering steep terrain along the German-Belgian border, seemed to favor the defender. German forces had constructed extensive fortifications, turning the forest into a defensive network that channeled American attacks into killing zones. German commanders, including Oberst Engel of the 275th Infantry Division, were confident that American numerical superiority would be negated by terrain. The forest canopy reduced visibility, made aerial observation difficult, and provided overhead cover that degraded artillery effectiveness. German troops in reinforced bunkers and log-covered foxholes felt relatively secure. American artillery doctrine for forest fighting had initially followed conventional patterns. Forward observers called for fire from nearby batteries, achieving local effect but lacking concentration. The thick forest made observation difficult and reduced the effectiveness of traditional artillery employment. German defenders, veterans of years of combat, knew how to use terrain and fortifications to survive artillery. Bombardment. What the Germans did not anticipate was the systematic development of techniques specifically designed for forest warfare using massed fires principles. American artillery planners, studying the problem with engineer-like precision, had determined that coordinated fires from multiple batteries could saturate target areas even when individual battery fires would be ineffective. The key insight was mathematical. A single battery firing into forest might achieve 15% effectiveness, with most shells absorbed by trees or exploding harmlessly in the canopy. But 12 batteries firing simultaneously would overwhelm the forest's ability to absorb shells, creating overlapping impact zones that would devastate anything in the target area regardless of cover. The Americans began developing target folders for Hürtgen Forest positions, pre-calculating firing data for known German strongpoints. Fire direction centers prepared multiple fire plans, each involving 10 to 15 battalions, ready to execute on request from forward observers. The preparation was methodical, systematic, unglamorous, and devastatingly effective. On November 7th, when Oberst Engel's forward battalion prepared to repel another American attack near Schmidt, they were confident in their positions. The bunkers had been constructed over weeks, using reinforced concrete and heavy timber. Foxholes had overhead cover of logs and earth. The terrain channeled attackers into predetermined kill zones covered by machine guns and mortars. When the American forward observer called for fire support at 1406, he used a simple code phrase and coordinate. The request went to the 28th Infantry Division Fire Direction Center, which immediately contacted Corps Artillery. Within 90 seconds, 12 battalions had been tasked, firing data calculated, and execution time coordinated. At 1407, 144 guns fired. The shells had been launched from batteries the German defenders had never seen, calculated to arrive simultaneously despite traveling different distances at different velocities. 105mm shells fired at high angle from close range arrived at the same instant as 155mm shells fired at lower angle from greater distance. The concentration was not just about the number of shells, it was about their simultaneous arrival, creating a moment of devastation that overwhelmed the target's ability to absorb impact. Individual shells might detonate in tree canopy or be absorbed by earth. 3,000 shells arriving in 90 seconds saturated the forest, creating a zone where survival became mathematically improbable. German survivors, and there were few, described the experience as incomprehensible. There was no warning, no preliminary ranging shots, no gradual increase in intensity that might allow soldiers to seek better cover or retreat. One moment, relative quiet. The next moment, the world exploded. The bunkers that had seemed secure collapsed under repeated impacts. Timber overhead cover that might stop individual shells was splintered by dozens hitting in succession. Foxholes that provided protection from conventional artillery became death traps as shells detonated in the trees above, driving fragments and wood splinters downward at lethal velocities. The American infantry attacked 15 minutes later, advancing through devastation that shocked even them. German positions that would normally have required hours of fighting to reduce had been obliterated in 90 seconds. Survivors were too dazed to offer effective resistance. The attack that German doctrine suggested should have failed achieved its objectives with minimal casualties. Oberst Engel's after-action report, captured after the war, provides crucial insight into German reaction. He wrote, "American artillery has achieved coordination exceeding our previous understanding. Multiple battalions fire as single unit with precision suggesting central control and calculation beyond our capabilities. Traditional defensive positions provide inadequate protection, request immediate guidance on counter-tactics." The response from higher headquarters revealed the depth of German misunderstanding. Engel was informed that he had likely encountered a lucky concentration, that Americans lacked the training and organization for systematic massed fires, and that improved positions and better camouflage would solve the problem. This response would prove catastrophically wrong. Part 2, continuing. The ability to execute massed fires from 12 or more battalions represented not just tactical innovation, but a manifestation of American organizational and industrial capability that German military tradition had not prepared them to understand. The Germans had spent decades developing professional military excellence based on individual skill, unit cohesion, and flexible command. They had not anticipated an enemy that would approach warfare as an engineering problem solved through systems and standardization. The mathematics underlying American massed fires were complex but not beyond German understanding. What the Germans could not replicate was the organizational ecosystem that made those calculations routine and reliable. Every massed fires mission required knowing the precise location of each battery, the exact distance to the target, the muzzle velocity of each gun type accounting for barrel wear, the weight and ballistic coefficient of each shell type, meteorological conditions, including wind speed and direction at various altitudes, air temperature and density affecting shell trajectory, and the rotation of the Earth for extreme-range fire. German artillery officers understood these variables perfectly. What they lacked was the systematic infrastructure to collect, process, and distribute this information rapidly across multiple battalions. American fire direction centers operated like industrial production facilities, processing fire missions with standardized procedures that transformed complex calculations into routine operations. The graphical firing table, a device that looked deceptively simple, embodied this systematic approach. It allowed trained operators to solve ballistic equations graphically in seconds rather than through lengthy calculations. An American Fire Direction Center team could calculate firing data for a 12-battalion mission in under 3 minutes. German artillery headquarters might require 20 minutes to coordinate 4 batteries if communication lines remained intact. This speed differential had profound tactical implications. American infantry could call for massed fires on targets of opportunity, hitting German assembly areas or counterattack formations before they could disperse. German artillery, slower to concentrate, arrived too late or hit empty positions. The Americans were not just firing more shells, they were firing them faster and more precisely than German doctrine had anticipated possible. The training system that produced this capability astounded German professionals who studied it after the war. The United States Army had trained thousands of fire direction specialists in less than 3 years, more than Germany had produced in decades of professional military education. At Fort Sill, Oklahoma, the Field Artillery School compressed centuries of artillery science into 17-week courses that transformed civilians into skilled mathematical practitioners. The training emphasized practical application over theoretical knowledge. Students performed thousands of simulated fire missions until the procedures became automatic. By graduation, a competent fire direction team could coordinate a 10-battalion mission as routinely as German crews served individual guns. This mass production of technical expertise represented an approach to military education that German tradition, with its emphasis on long professional development, had not conceived. The Americans were applying industrial management principles to military training, standardizing procedures, measuring performance, and scaling successful methods across the entire army. By late 1944, every American artillery battalion in Europe operated with identical procedures, used identical equipment, and could integrate seamlessly into corps-level fire plans. German artillery, despite its professional excellence, lacked this standardization, with each division developing somewhat different procedures based on commander preference and local tradition. The execution of massed fires required not just training and organization, but overwhelming material resources. A single 12-battalion mission might expend 3,000 shells, more ammunition than some German divisions received in a month. During the November 1944 battles in Hürtgen Forest, American artillery fired over 400,000 rounds, creating logistical demands that the German army could not have sustained even if it possessed the organizational capability. The American logistical system delivered ammunition to batteries with reliability that German quartermasters found incomprehensible. Trucks ran continuously from supply dumps to firing positions, creating an unbroken flow of shells. The famous Red Ball Express, dedicated truck convoys supplying forward units, moved 6,000 tons of supplies daily across France, including vast quantities of artillery ammunition. German logistics, by contrast, relied heavily on horse-drawn transport, even in 1944. The Wehrmacht employed over 2.75 million horses throughout the war, more than in World War I. While American trucks delivered palletized ammunition directly to gun positions, German horses struggled through muddy forest trails. This logistical disparity meant American batteries could sustain high rates of fire indefinitely while German guns rationed ammunition. The quality of American ammunition also exceeded German expectations and capabilities. Each shell was manufactured to tolerances that ensured consistent performance. Propellant lots were tested extensively to guarantee specified muzzle velocity. Shell weight was controlled within grams. This consistency was essential for massed fires, where shells from different batteries had to arrive simultaneously, despite being fired from different distances. Preparing and narrating this type of story took us long efforts and hard work. So if you are enjoying the story, please consider subscribing to our channel. German ammunition quality had deteriorated markedly by 1944. Slave labor in dispersed factories, subjected to Allied bombing and increasingly desperate production quotas, could not maintain pre-war standards. Shell weights varied, propellant quality was inconsistent, and fuses showed growing failure rates. German battery commanders conducting test fires with new ammunition often discovered variations requiring significant corrections to firing data. This quality differential compounded organizational disadvantages. Even if German fire direction centers could calculate massed fires as quickly as Americans, they could not rely on their ammunition to perform consistently. The Americans could fire shells manufactured 6 months earlier in Pennsylvania, alongside shells produced last week in Missouri, confident both would have identical ballistic characteristics. Germans could not make such assumptions. The meteorological services supporting American artillery demonstrated another dimension of systematic superiority. Accurate massed fires required precise knowledge of atmospheric conditions affecting shell trajectory, wind speed at various altitudes, air pressure, temperature, and humidity all influenced where shells landed. Small errors, acceptable for single battery fires, became catastrophic when trying to converge shells from 12 battalions on a 400-meter square. American Corps artillery included dedicated meteorological sections taking readings every 30 minutes. Radio soundings, weather balloons carrying transmitters, provided atmospheric data up to 30,000 feet. This information was immediately distributed to all fire direction centers through communication networks. German meteorological services, disrupted by years of war and loss of trained personnel, could not match this systematic approach. During the battle for Schmidt in early November, weather conditions changed rapidly. Morning fog gave way to afternoon rain, with variable winds and shifting temperatures. American fire direction centers received updated meteorological data every 30 minutes, adjusting firing calculations accordingly. German artillery, working with outdated information or local estimates, found their accuracy degrading precisely when American accuracy remained consistent. The psychological impact of massed fires on German troops exceeded the physical destruction, though that was substantial enough. Traditional artillery bombardment followed predictable patterns. Initial ranging shots warned of incoming fire. Gradual increase in intensity allowed soldiers to seek cover. Prolonged bombardments created rhythm that veterans learned to endure. None of these coping mechanisms applied to American massed fires. The instantaneous nature of 12 battalion concentrations removed psychological preparation. German medical services documented unprecedented rates of what they termed artillery-induced trauma, conditions similar to shell shock, but developing more rapidly and proving more resistant to treatment. Soldiers who had functioned effectively after hours of Soviet barrage were broken by minutes of American massed fires. One captured German medical report from December 1944 described symptoms unique to massed fires exposure. Soldiers exhibit paralysis triggered by sudden sounds, inability to process simultaneous stimuli, and profound fear of coordination itself. Unlike traditional combat neurosis, which may improve with rest, these symptoms persist even after evacuation. Recommend immediate study of countermeasures. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The countermeasures never materialized because the problem was not psychological but material. German soldiers were not failing mentally. They were responding rationally to a level of firepower concentration that made survival in traditional positions nearly impossible. The solution would require fundamental changes to defensive doctrine, dispersing forces to degrees that sacrificed defensive strength, or constructing fortifications far beyond combat engineering capabilities. The encirclement and destruction of German forces in the Hürtgen Forest through November and December 1944 demonstrated the systematic application of massed fires doctrine. American planners identified every German strongpoint through aerial photography, forward observer reports, and signals intelligence. Fire direction centers prepared target folders with pre-calculated firing data for each position. When American infantry attacked, they advanced behind rolling concentrations of massed fires. Every German position along the attack route was subjected to 12 to 15 battalion concentrations in sequence. The fires walked forward at predetermined rates, synchronized with infantry advance. German defenders survived the bombardment of their own positions, only to face immediate infantry assault while still stunned. The town of Wassenach, a crucial strong point dominating approaches to Schmidt, fell on November 9th after a preparatory bombardment involving 17 battalions. German defenders had fortified every building, prepared extensive obstacles, and positioned interlocking fields of fire. The position should have required days of costly fighting to reduce. American fire direction centers coordinated fires from the 28th Infantry Division, attached corps artillery, and Army-level assets totaling over 200 guns. The bombardment lasted 12 minutes, delivering approximately 4,000 shells on a town measuring 800 meters by 400 meters. German survivors reported that the town ceased to exist as a defensible position. Buildings collapsed, obstacles were destroyed, and defenders were too disoriented to offer coordinated resistance. The after-action report from the German 275th Infantry Division, written 3 days after losing Wassenach, reveals the depth of German tactical crisis. American artillery coordination has rendered traditional defensive positions untenable. Concentrated fires from multiple battalions arrive without warning, achieving devastation exceeding prolonged Soviet bombardments. Attempts to disperse forces reduce defensive effectiveness. Attempts to concentrate invite immediate artillery response. No tactical solution identified within current capabilities. Higher German command initially dismissed these reports as defeatism or exaggeration. Field Marshal Walter Model, commanding Army Group B, responded that concentrated artillery fire was not new, that German forces had endured worse on the Eastern Front, and that proper defensive preparation would solve the problem. This response demonstrated fundamental misunderstanding of what American massed fires represented. Soviet artillery, though numerous and often devastating, achieved concentration through physical massing. Hundreds of guns positioned in a small area could deliver overwhelming firepower, but this concentration was visible, vulnerable to counter-battery fire, and inflexible. Once positioned for attack on one sector, Soviet artillery required hours to shift to another target. American massed fires achieved concentration without physical massing. Batteries spread across 20 miles could converge their fires on any target within range, then shift to another target within minutes. This meant every German position within range of American artillery, which meant virtually the entire front line, was vulnerable to 12 battalion concentrations with no visible warning. The flexibility had profound operational implications. German commanders could not identify where American artillery was concentrated because it was not concentrated physically. Counter-battery fire could target individual batteries, but could not suppress the entire system. Moving reserves to threatened sectors risked encountering massed fires on approach routes. Every tactical decision became complicated by artillery that could materialize anywhere within minutes. The Battle of the Hürtgen Forest also demonstrated American willingness to refine doctrine based on combat experience. Forward observers reported that tree bursts, shells detonating in forest canopy, were particularly effective in wooded terrain. Fire direction centers began calculating missions using mixed fuses, some set for impact, others for airburst, maximizing effectiveness against dug-in positions under overhead cover. By December, American artillery was routinely firing what they called mixed missions, combining different shell types, fuse settings, and even calibers in single concentrations. A typical mission might include 105mm shells with super-quick fuses for surface effect, 155mm with delayed fuses for bunker penetration, and time-fused shells for airburst over trenches, all arriving simultaneously from 12 or more battalions. German defenders discovered that the fortifications designed to withstand conventional artillery offered inadequate protection against these mixed concentrations. Bunkers that could survive impact fuses were vulnerable to airburst fragments entering firing ports. Trenches that protected against surface bursts were death traps under tree bursts. Dispersed positions reduced vulnerability to any single shell type, but left troops exposed to the variety of effects in mixed missions. The Germans attempted several counter-tactics, each proving inadequate. Deep bunkers with multiple layers of overhead cover could survive even massed fires, but required construction time and materials unavailable under combat conditions. Extreme dispersion reduced casualties from individual concentrations, but spread forces too thinly to hold positions. Rapid counterattacks attempting to close with American infantry before artillery could respond were devastated by pre-planned defensive fires. One German innovation, emphasized in December 1944 directives, was immediate displacement after engaging targets. German batteries would fire briefly, then move to alternate positions before American counter-battery fire could respond. This tactic, effective against conventional artillery, had limited success against American massed fires because American fire direction centers tracked multiple batteries and could coordinate counter-battery fires from core-level assets faster than German batteries could displace. The American capture of German artillery fire direction documents in December provided insight into the sophistication gap. German procedures, though professionally executed, were designed for coordinating 4 to 8 guns, working closely with forward observers. The concept of coordinating dozens of batteries spread across core boundaries, calculating firing solutions for simultaneous impact, and executing missions within minutes simply did not exist in German doctrine. German attempts to develop similar capabilities revealed systematic disadvantages. They understood the mathematics and could, in theory, calculate coordinated fires, but they lacked standardized ammunition enabling accurate predictions. They lacked communication infrastructure supporting corps-wide coordination. They lacked trained personnel in sufficient numbers. Most fundamentally, they lacked the industrial foundation producing equipment and ammunition in quantities, making such tactics sustainable. A captured German assessment from January 1945, written by a staff officer who had studied American artillery procedures, concluded, "Enemy coordinated fire technique represents systemic advantages in manufacturing standardization, communication technology, personnel training, and logistical sustainment. Replication would require fundamental restructuring of artillery organization, massive investment in communication infrastructure, complete standardization of ammunition production, and training programs, producing technical specialists in numbers currently impossible. Effective countermeasures beyond German capabilities under current conditions." This assessment was brutally accurate, but came too late to influence German defensive doctrine. By early 1945, the pattern had been established. American attacks would be preceded by massed fires missions that destroyed German positions in minutes. German counterattacks would be caught by pre-planned fires that devastated assault formations before they reached American lines. The tactical balance had shifted decisively in favor of the side that could coordinate hundreds of guns as easily as Germany could coordinate handfuls. The crossing of the Ruhr River in February 1945 demonstrated massed fires at operational scale. The Ninth Army, preparing to force the river, concentrated over 800 artillery pieces from multiple corps. The bombardment plan called for sequential massed fires, missions walking across German positions for 3 hours before the assault. Preparing and narrating this type of story took us long efforts and hard work. So, if you are enjoying the Kufferli story, please consider subscribing to our channel.